Hello students, from today we start with the derivatives. But first of all, what is a derivative? A derivative is a function whose value gives the slope or the gradient at a point on the graph of a function. We have different types of functions. It may be a linear function, a quadratic function, a cubic function. These are polynomial functions. We have exponential function. We have logarithmic function. We have trigonometric function. We have so many types of functions. And we have derivatives of all those functions. And the derivative is itself a function whose value a function has its values. For different inputs we have different outputs. So derivative is a function whose value gives the slope or the gradient at a point on the graph of that function. We will be understanding the meaning of this statement more in our this session and in our coming sessions. So first of all, we take up the line function, the linear function. The value of the derivative of any linear line graph, which will be the graph of a linear function, is the slope of that line and is the same at all points of the graph. Because the slope of a straight line is the same for all the points on the line, therefore the value of the derivative will also be the same for all points on the graph. So this is the horizontal line that I have taken, whose equation is y equals 2. And this is an unending line, but since I usually take the graphs from Desmos, which doesn't have the arrows, which do not give the arrows on the two ends, therefore we do not have any arrows at the ends, but it is an unending line. It is a horizontal line parallel to the x-axis. What will be the derivative? The derivative is written as dy by dx, and this is equal to the slope. What is the slope formula? Y2 minus y1 over x2 minus x1, and I have taken these 2 points. You may take any other point as well. I have taken 0, 2 and 4, 2, so the slope will be 2 minus 2 over 4 minus 0, which is equal to 0 because 2 minus 2 is equal to 0. Now you may have any other horizontal line, but whichever horizontal line you take, it will be having an equation of the form y equals some number k, constant. And for all the points on that line, the y coordinates of all the points on that line will be equal to k. Therefore, the numerator will be k minus k, which will be equal to 0. Hence, the derivative of all the horizontal lines will be equal to 0. Okay. Now we come to any normal, means this is a special, these are special lines, but we are taking this is an inclined line. So this is just an usual line. So what will be the derivative of this line? The equation of this line is y equals x, and the 2 points that I have taken, I have to take 2 points because I want the slope or the gradient, hence I have to take 2 points. I have taken 0, 0 and 2, 2. Therefore, the derivative or dy by dx will be equal to 2 minus 0 over 2 minus 0, which is equal to 1. So the derivative of this particular line function is equal to 1. And this will be the same regardless of which points we take on the graph, which 2 points we take on the graph. Doesn't matter, the value of the slope will be the same. And it will be a non-zero number. It may be positive, it may be negative, but it will be a non-zero number. And we have another third type of line, which is a vertical line. And the equation of a vertical line will be x equals k. I have taken x equals 2. You can take any other number. X equals 2, x equals 0 is the y-axis. X equals 1, x equals minus 10. All are vertical lines perpendicular to the x-axis. The derivative of a vertical line of the form x equal to 2 is undefined since its slope is undefined. Why is the slope undefined? Because the x coordinate of every point on this line x equals 2 or x equals k will be having the value of k, in this case 2. Therefore, the denominator will be 2 minus 2 will be equal to 0, which will be equal to 0. And we cannot have a 0 in the denominator, hence the slope is undefined, and therefore the derivative of a vertical line is undefined. Okay. Now we come to curvilinear graphs. These were just line graphs, but we have other types of graphs as well. The derivative of the value of the derivative of any curvilinear graph is different at different points on the graph, since the slope of the curve is different at different points on the graph. Let us see. The derivative of any curve at a point is equal to the slope of the tangent. Tangent is a straight line, so it will be equal to the slope of that straight line tangent to the curve at that point. So that is how we get the derivative of any curve at a particular point, because it is not the same at all the points. Like this is a curve, it is a parabola, and it is the graph of this equation y equals x squared. And I have taken 2 points. This one is the origin through which this parabola passes, 0, 0, and this is 2, 4. And they have said that derivative of any curve at a point is equal to the slope of the tangent. Now, therefore, I have drawn these two tangents. This is the horizontal line, the x-axis is the tangent at the point 0, 0, and at the point 2, 4, this green line is the tangent to the curve. Okay. And we are seeing the value of the derivative of dy by dx is equal to 0 for the point 0, 0, because the tangent is a horizontal line. Therefore, its slope is equal to 0. Hence, the derivative dy by dx is equal to 0. Hence, the dy by dx, or the derivative of this curve at this point, is equal to 0. We have to mention at this point. But for 2, 4, the value of the derivative dy by dx for the point 2, 4 is equal to some non-zero number. I have not calculated the tangent. I have to take another point on this tangent. I haven't calculated the slope rather of the tangent. I can calculate the slope if I take another number, another point on the tangent. But I know that it will be some non-zero number. It will be a positive number in this case. But if you draw a tangent for any of the points on this side, it will be a negative number. But it will not be equal to 0. Since it is not a horizontal line, its slope will not be equal to 0. Hence, the derivative will not be equal to 0. It will be a non-zero number, and since it is not a vertical line, it will not be undefined as well. Therefore, we are seeing that we are having two values of the derivative at two different points of the same curve, which refers to the same function or the same equation y equals x squared. Okay, that is what is said by it is different at different points of the graph. Okay. If the function expression is written as y equals some expression, algebraic expression like y equals x squared, it may be some algebraic expression, it may be a constant as well, like we have seen y equals 2. Then the derivative is written as dy by dx, which we are seeing so far, and is read as dy by dx. But if the function expression is written as f of x equal to some expression, this could have been written as f of x equal to x squared. If the function expression is given in this form, then the derivative is written as f dash x or f prime x. This is read as f dash x or f prime x. Okay. So students, this is all for our today's session. I'm Nilanjana Sanyal, and this is my YouTube channel, NS Online Math Classes. Thank you for watching this video till the end. Please like and share this video if you find it useful. And please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. Please let me know if you have any question in the comment area. I'd be happy to help you. Bye.